Hi students, in this video I am going to give you a small clarification while solving the numericals of chapter solution under the heading colligative properties. Okay, so we know very well what the colligative properties that depends on number of solute present in our solution, isn't it? So we have four in this syllabus, that is RLVP, relative lowering of vapor pressure, then elevation in boiling point, depression in freezing point, then osmotic pressure. So among these four, I am going to discuss the clear idea about this delta B and delta TF while solving the numericals. Okay, so see children, நம்ம problem solve பண்றப்ப okay, and the final answer of TB TF பாத்தீங்கன்னா டிகிரி செல்சியஸா கெல்வின்ல அப்படின்னு சொல்லிட்டு நல்ல தெரிஞ்ச கான்செப்டா இருந்தாலும் சில பேர் எக்ஸ்பிரஸ் பண்றப்ப தப்பு பண்றாங்க. ஸோ ஆல்வேஸ் ப்ரிஃபர் டு கோ ஃபார் கெல்வின். ஆனால் இந்த சேஞ்சஸில் பார்த்தீங்க அப்படின்னா நம்மளுக்கு மேக்னிடியூட், தட் இஸ் வேல்யூ ஆஃப் டெம்பரேச்சர் பார்த்தீங்கன்னா there is no difference whether it is in degree Celsius or in a Kelvin. Shall we check this out? For example, we already know that the boiling point of solution which consists solute and solvent is always higher than the boiling point of pure solvent. Yadanaala, the escaping tendency of our solvent from the solution is little bit getting reduced compared to pure solvent because of the presence of solute. So we know all this one. When we relate that with the vapor pressure, see where the vapor pressure is inversely proportional to boiling point always. It is very clear. So in this point, I can going to take example, that is let me take 100 degrees Celsius of solution boiling point, and TB is say around the boiling point of pure solvent, let it be 60 degrees Celsius. So what is the difference when I am taking? Then delta TB is going to be 40 degrees Celsius. Okay, so this is delta TB in terms of degrees Celsius. Suppose in the questions in terms of Kelvin you should be very careful, because the students degree Celsius they stop panniranga, but question la endiyavadhu endla Kelvin nu ketunda they are neglecting it. Okay, I am going to check with the Kelvin also. So if I take TB in terms of Kelvin, say how to convert 100 degrees Celsius into Kelvin and 273 into this value. So we will get 373 Kelvin minus, when I add 273 and 60, we will get 333. So 333 Kelvin. When I take difference children, how much I am getting? 0.4. See, around 40 Kelvin. So whether it is in a degree Celsius or in a Kelvin, okay, in terms of when I am talking about difference in TB, there is no change in the values. Okay, so see to that, whether they are asking questions in degree Celsius or Kelvin, don't do that mistake at the end. Okay, similarly when you go for delta TF, where TF is the freezing point of the pure solvent, freezing point of solution, and TF naught is the freezing point of the pure solvent, we know that this temperature always, the freezing point of pure solvent is higher than the solution. When you add solute to that solvent, when it becomes a solution, the freezing point is still going down. Alright, that's why we call that as depression and freezing point. Okay, so in this case also, when you take in degree Celsius or in a Kelvin, delta TF value is not going to change. Instead, in the question they are asking for TF. Then you should be very careful, because degree Celsius and Kelvin is different. Example, just I am taking, see, 2 degrees Celsius be the freezing point of the difference, and this is, let it be TF naught. Okay, and what about TF? Let us take below than this. Okay, so I am going to take, say, minus 12 degrees Celsius. So what is the value of TF is going to be? TF naught is going to be minus into minus plus here. When you take that plus to the other side, you will get 2 degrees Celsius minus 12 degrees Celsius. So as a result, I am getting 10 degrees Celsius. If 10 degrees Celsius is exposed here, in terms of Kelvin, when I am changing, look at this value, 273 minus 10. So I am getting 263 Kelvin. See, when I take this TF naught, which is the freezing point of a pure solvent in terms of degree Celsius and Kelvin, it is different. So what we are going to conclude here while working out your problem, please take care. When it is expressed in delta TB, when you want to find the value of delta TB, the values are going to be same, and we concentrate on the units expression. When you take whether you are calculating TB or TB naught or TF naught or TF individually, separately, then degree Celsius and Kelvin has to be in a different values. Okay, so these small mistakes we often do. Don't do this while solving the numericals in solution chapters. Okay.